Hello bachcho, let's read this question. Question says standard Gibbs energy of reaction at a certain temperature can be computed as del G is equals to del H minus T del S, and the change in the value of del HR and del SR, that is change in enthalpy of reaction and change in entropy of reaction for a reaction with temperature, can be computed as follows. Here it is given that temperature T2, the change in enthalpy at temperature T2 minus change in enthalpy at temperature T1. These are in standard state. It is equals to standard heat capacity, change in heat capacity at constant pressure T2 minus T1. Here that is del S T2 minus del S T1, it is equals to del Cp ln T2 by T1. Del G is equals to del H minus T del S, and del G is equals to minus RT ln K equilibrium. Consider the following reaction. CO gaseous plus 2H2 gaseous is in equilibrium with CH3OH gaseous. Given that enthalpy, change in enthalpy of formation for CH3OH is equals to minus 201 kilojoule per mole, change in enthalpy of formation for CO gaseous, it is equals to minus 114 kilojoule per mole. The entropy of CH3OH gaseous equals to 240 joule per Kelvin per mole, and the entropy for H2 gas, it is equals to 29 joule per Kelvin per mole. Entropy for CO gases is equals to 198 joule per Kelvin per mole, and molar heat capacity at constant pressure for H2 is equals to 28.8 joule per Kelvin per mole, and CPM, that is molar heat capacity at constant pressure for carbon monoxide, is 29.4, and molar heat capacity at constant pressure of CH3OH is 44 joule per Kelvin per mole, and ln 320 divided by 300 is equals to 0.06. All data is given at 300 Kelvin. Enthalpy of reaction, change in enthalpy of reaction at 320 Kelvin is, options are minus 288.86 kilojoule per mole, minus 289.1 kilojoule per mole, minus 87.86 kilojoule per mole, and none of these. Now we have to calculate the values. Now firstly we can write that key concept. So see, in this question it is given that it has asked about the change in enthalpy at 320 Kelvin. These are the data at 300 Kelvin. So we can write that here, that for temperature T2, enthalpy of change in enthalpy of reaction at temperature T2, it is equals to enthalpy of change in enthalpy of reaction at temperature T1 plus del R Cp naught, that means standard change in standard molar heat capacity at constant pressure T2 minus T1. Now we can calculate the value of this and this, so that we can directly calculate the value. Now this value at temperature T1, that is at 300 Kelvin, the value comes out to be, here it is given that for this reaction the product side summation of enthalpy, change in enthalpy of formation, here we can write summation of change in enthalpy of formation at product side minus summation of change in enthalpy of formation at reactant side. Now at product side only CH3OH is present, the value is given, it is equals to minus 201. So minus 201 minus, at product side here CO and H2 is present, so for H2 the value of standard enthalpy of formation is 0, and for CO it is given minus 114. So minus 114. So the value comes out to be this value, here it is comes out to be minus 87 kilojoule per mole. Now we can calculate the value of Cp naught, del Cp naught, that is change in molar heat capacity at constant pressure for this reaction. It is equals to summation of Cp at product side minus summation of Cp at reactant side. Now the values are given at product side, here CH3OH is present and the value is equals to 44, minus at reactant side here CO and 2H2 are present, so for CO the value is 29.4, and for H2 the value is 2 multiplied by, here 2 moles are present, so 2 multiplied by 28 point, here it is 28.8. These are the datas in joules. So we can write 44 minus 29.4 plus, it is equals to 57.6. Now 44 minus, here it is equals to 87. The value comes out to be minus of 43 joule per Kelvin per mole. Now this is the value of del R Cp naught. Now we can substitute the values in this formula. So now we can calculate that we have to calculate change in standard enthalpy of formation at 320 Kelvin. It is equals to the value at 300 Kelvin. It is equals to minus of 87 plus the value of change in molar heat capacity at constant pressure. It comes out to be 43, minus 43. So here we can write minus 43 multiply by T2 minus T1 is 320 minus 300. Now this value given in joule, so we can calculate the in kilojoule by multiplying 1000, because this value, the enthalpy, is given in kilojoules. So now we can calculate the value of enthalpy of reaction at 320 Kelvin comes out to be minus 87.86 kilojoule per mole. This value is given in option C, hence option C is the correct choice for this question. This option C is the correct choice for this question. Hope you understood it well. All the best and thank you.